Hello, for the second problem of week 7a, I chose question number 11, and it states, using the Bohr model, determine the ratio of the energy of the nth or orbit of an ionized atom with 5 protons in the nucleus, Z equals 5, and only a single electron orbiting the nucleus to the energy of the nth orbit of a hydrogen atom. So for this problem, they want us to calculate ratio. That's why it's going to be no units. But here I have my Bohr model. So they're saying compare the ratios of one ion to a hydrogen ion. And it says that there's 5 protons in the nucleus. So this is our 5 protons in here in the nucleus. And then I have 1 electron orbiting around it. And then for a hydrogen atom, we know that I believe I said 5 protons, but there's 5 protons in here. And then there's 1 proton for a hydrogen atom. We know that by looking at the periodic table also. And then, so it's wanting to calculate the ratio of the energy. So we have to compare the two energies. And we do this by using the Bohr energy level in electron volts equation. And so first I do it for the energy of this ion that we have. And this equation states that E equals the energy of the electron while it is in a specific orbit around the nucleus. Its SI units is joules. And then Z equals the atomic number, the amount of protons in the nucleus. Its SI units is unitless. N is the principal quantum number. It's the energy level of the electron, or it's basically showing just stating what energy level you're at. And then its SI units are also unitless. And then this number 13.6 eV is the Bohr energy constant for hydrogen in relation to the ground state energy of the hydrogen atom. Its SI units is electron volt, which is eV. And then for this problem, we were able to calculate, so I was able to plug everything in, so that it's En, it's just the ion or whatever you want to. It could be a hydrogen ion or just whatever, equals negative 13.6 eV times Z squared divided by N squared. So that's what I did here, and I filled it in. This is for our ion that they told us that has 5 protons, so I put the 5 in for the Z. And then our N is unknown, and that's what we'll be solving later. And so then we're left, we give ourselves this ratio to be able to calculate the ratio of them later. And they're both going to be negative because we have a negative out in front, and that's a part of this equation. So then I do it for the hydrogen, and I do EH equals 13.6 eV, 1 squared, because there's only 1 proton in there, and nucleus, and then N squared. And we don't know, so we get these ratios next to each other. But we want the ratio of an ion divided by EH. So we put the ion on top, and then we put the 13.6 on the bottom, and those cancel out. So 13.6 goes into 340 25 times, and those negatives cancel out also, which makes sense because we're doing a ratio. So that means for determine the ratio of the energy of the nth orbit and only a single electron. So basically our ratio is stating that for every 25 there is 1 of these. And I put that here, 25, it's unitless.